So today we're going to talk about the intermediate value theorem. Since a person's height is a continuous function of time, if a child had a height of 58 inches at age 11 and a height of 64 inches at age 14, then the child's height took on every value in between 58 and 64 inches for some time between the age 11 and 14. This is a simple example, okay? Of an important theorem of calculus that we call the intermediate value theorem. What this is telling you is the function must be continuous, okay? Because the child suddenly is not going to jump from one height to the other, okay? So, as you can see, the intermediate value theorem has three statements, okay? So, the first one is f of x needs to be continuous on the closed interval a to b. After that, if f of a is different of f of b, there's a k in between and there's a k in between f of a and f of b, then there exists a number c in between a and b for which f of c is equal to k. Okay, so visually what's happening here? What we have is that the function y equals f of x, that it's continuous. Okay, so we have something that looks like this. Let me see. B. Okay, so we have something that looks like this. Okay. Okay. So it's continuous. This function that you are seeing over there, actually, it's continuous. Okay. K is in between f of a and f of b. Okay. So what are they talking about? Okay. So here, okay, let's say that this is a point and this is a point. Okay. So you know that this is going to be f of a. Okay, and then f of b is going to be over here. Okay, so f of b. Okay, now what's k? K is going to be this value that it's going to give you the output. Okay, that's going to be f of c. You want that f of c to be equal to k. Okay, and that's the theorem what the theorem is talking about. Okay. So it's an existence theorem. We call this type of theorems existence theorem. Okay, so let's look at the example. You need to determine if the IVT or intermediate value theorem holds for the given value of k. B, if the theorem holds, find a number c for which f of c is equal to k. If the theorem does not hold, give the reason. And for c, you need to draw and sketch the curve. Okay, so what are you going to do for the first one that you are seeing there? You might tell me, oh, it's a rational function. True, but look at the interval, 2.5 to 7. You know that we have a problem at 2, and you can even draw your asymptote here at 2, right? But the part that we're looking at is basically this part. Okay, so it's continuous. Okay, so clearly from that, from your knowledge from pre-calc, you know that f is continuous on the interval 2.5, 7. Okay. The second condition of the IVT, you know that f of 2.5, okay, is going to be equal to what? You plug it here, so you have 1 divided by 0.5, so this is going to be 2. Now we need to find f of 7, okay, f of 7, you plug 7 here, so you have that it's 1 over 5, okay, so clearly they are different, okay. So what do you have? Condition number 3 of the IVT that you have over here is if k is in between these two. Okay, so what's your k in this situation? K apparently is 1/4. Okay, so you have is 1/4 in between 1/5 and 2. Absolutely. So this is true, this is true, and this is true. Thus, okay, the IVT holds. Now, since the IVT holds and we're done for part A, we need to find a number c for which f of c equals k. Okay, so for B, what you need to do is you have that 1/4 is your k, and this is going to be the output for some value, okay, that you are looking for when you plug it in the function. So you equalize this value that you have, k, to your equation of the function, okay, and solve it for x. Okay, once you solve it for x, what do you have? You cross multiply, so you have that this is going to be 4 equals x minus 2, and from that it's pretty easy to see that you know that apparently the value x equals 6 is the one that you have. Now you need to be very careful. Is this number 6 in between 2.5 and 7? Yes, it is. Okay, so since 6 it's an element of the interval 2.5 and 7, okay, I know that c is equal to 6. Okay, and that's your c. Please remember that I haven't called it c up to here because I don't know if it meets the conditions. I call it c at the very end because it's when I know that actually the conditions are met, because I know that c is 6 is in between 2.5 and 7. Okay, so that's what you have for the first example. Now for the second example, what we have over here, okay, so you have a quadratic equation here, a quadratic function. Okay, so it's pretty easy to see. A quadratic function or a polynomial function, as you learned back in pre-calc, they are always continuous functions. Okay, they are continuous in all real numbers, moreover in a small interval. Okay, so whenever you have an integer exponent in the x and it's a polynomial, you can conclude immediately that f is continuous just because it's a polynomial. Okay, on the interval -1, 2. Okay, the second condition that you have here that you need to double check is you need to compute f of -1. You are going to plug it in as usual, nothing too scientific here. Okay, so when you plug it in there, you know that this is going to be equal to -10. Okay, and then you look for your f of v, that in this case your b is 2, so plug the 2 there, so you have 4 plus 20 minus 6, and you have that value is going to be equal to 8. Okay, and it's not 20, it's 10. I don't know what I was thinking. Okay, so you have this. Clearly they are different. Okay, so second condition met. Now the third condition that you have is, what was it? If the value of k is in between what? 10 and 8. -10 and 8. Of course it is. Okay, so you know that this is completely true. Okay, check. So what are you going to do? Does the IVT holds? Okay. Okay. For B, what do you have? For B, okay. Since the IVT holds, what are you going to do? Take your C, which is for not C, K, excuse me, which is 4. You are going to equalize it to the equation that in this case you have, that is x squared plus 5x minus 6. Okay, after that you solve it. Okay, so what I would do here, I would solve it via this way. Okay, factoring, because you know it's the easiest. Okay, so you have this, and you're going to be like, oh, I don't want to factor because it's a horrible thing. True, true, true. So use the quadratic formula. Okay, so we use the quadratic formula. X is equal to minus 5 plus minus the square root of 5 squared, which is 25, minus 4 times 1 times -10. Everything divided by 2 times 1. Okay, so you have this, you plug it in the calculator, and you're going to have 2 values. Okay, this comes the tricky part. Okay, so when I plug it in my calculator, the first one, it gives me something like this, -6.531. Okay, and the second one, it gives me 1.531. Now you're going to tell me, oh, there's 2. Could happen that you have 2, but we need to check. We need to check what? That the condition is met. What condition? That this is in between this interval. Is it? Absolutely not. The -6 is not inside the interval, so this is not a C. Okay? Now, analyze this one. Is 1.531 inside this interval? Absolutely yes. So this is going to be your C. Okay? So you can conclude that since 1.531 belongs to the interval -1, 2, you can conclude that C is going to be 1.531, and that's pretty much it.